Hello students and welcome to another science online class. This is video number 6 for the topic properties of light, specifically total internal reflection and critical angle. Now, let's discuss first mirage. So, a mirage is a naturally occurring optical phenomenon in which light rays bend via refraction to produce a displaced image of distant object or the sky. So, the word comes to English via the French mirage from the Latin mirari, meaning to look at, to wonder at. So, in other terms, so it is the refraction in air due to the differences in the temperature of air and the surface. So, look at the first illustration. Akala natin parang oasis, no? Parang tubig. Pero, it is the sky. No? And then, the second illustration, tignan niyo yung itsura ng sun. So, it's an optical phenomenon. Okay? Now, let's discuss the total internal reflection. So, when a ray travels in a material of greater index of refraction, which can be represented by NA, towards a material of smaller index, which is represented by NB, total internal reflection occurs at the interface when the angle of incidence exceeds n critical angle. Okay? So, now, this occur when the angle of incidence is greater than the critical angle and having an angle of refraction equal to 90 degrees. Okay? So, that is total internal reflection. No refraction occur, pero reflection ang meron. So, now, let's discuss the critical angle. So, critical angle is defined as the angle of incidence that provides an angle of refraction of 90 degrees. So make particular note that critical angle is an angle of incidence value. Okay, for example, for the water and air boundary, the critical angle is 48.6 degrees. So we have a general formula here of critical angle. Sine critical angle is equivalent to NB divided by NA, where NA is greater than NB. Now let's have a sample problem. So determine a critical angle on air, water, okay, where air is less than water, which air has 1 index of refraction and water has 1.52 index of refraction. So using the general formula, so since we need to transfer the sin on the other side, it becomes it is sine -1 or arc sine. Okay, so let's do the computation. Sine -1 and then 1 divided by 1.52. So in this set, we have the quotient is 0.65789. And then sine -1, the computed value is 41.14. Now, in this illustration, if the angle of incidence is less than the critical angle, the light refracts away from the normal line. So again, there's a refraction in this illustration. Here, if the angle of incidence is equal to the critical angle, the light refracts at 90 degrees to the normal. Yeah. And for the last illustration, if the angle of incidence is greater than the critical angle, total internal reflection occurs. So there's no refraction happening on this illustration. Thank you for listening and have a great day.